All right, Algebra 1, talking 6.2 today. So, exponential functions. The equation for an exponential function is y equals a times b to the x, where a is what we call the initial value. So, that's when x equals 0, where is the graph? And x is typically like years or something. X is the exponent, so they'll tell you. And then B is when x equals 1, B is the formula y divided by a. So if you ever need to find a, just plug in 0 for x and solve for a. And if you ever need to find b, plug in a 1 for the x, and then just divide the y value divided by the a value. A couple rules here. When a is greater than 0, so when a is a positive number, there's an asymptote at y equals 0, and the graph is above the x-axis. And we'll see an example later. Whereas when a is negative or a is less than 0, there's an asymptote at y equals 0. And then the graph is below the x-axis. So we will see an example of an asymptote later on. Couple other things. The domain, just a reminder, is all the x values that the graph can be. So what can you plug in for x? The range is all the y values. So what can you get out for y? The x-intercept, you set y equal to 0 and you solve for x. The y-intercept, you set x equal to 0 and you solve for y. So let's graph something. We have y equals 7 to the x power, or the power of x. And to graph this, we're going to make a table and plug in some points for x and see what we get for y. Because if we get an x, y value, that'll be a point for our graph. So let's just pick some values for x and we'll see what y is. So we're going to pick -2, -1, 0, 1, and 2 to plug in for our exponent. And we're going to see what our y value is. So if we plug in -2 up here, that'll be 7 to the -2, or the power of -2. Remember, when we have a negative exponent, we need to make a fraction. So it'd be 1 over 7 squared, and 7 squared is 49. So we have the point -2, so that'd be -2, and then barely up at 1 over 49. Now, if x equals -1, that'd be 1 over 7 to the first. So that's just 1 over 7. So our point would be -1 and 1/7, again, just barely above the line. Anything to the power of 0. So if we take an x value of 0 and plug it in for this, it'll be 7 to the 0 power, which is just 1. So that'll be our y-intercept at 0, 1. And then we also can plug in 1, so we know the y value would be 7. And if we plugged in a 2, that's 7 squared, that's 49. So you can see that this graph goes up really, really fast after it kind of turns the corner around the y-axis, or the y-axis. And kind of notice as we go to the left, so as we go further and further to the left of the x-axis, these numbers are going to get smaller and smaller and smaller. They're going to keep being fractions, right? But they're never going to be a negative number because they're never going to cross the x-axis. And that is because, based on this rule, we have an asymptote at y equals 0. We have this asymptote at y equals 0. The domain, what can we plug in for x? We could plug any number we wish into this x. So our domain is all real numbers. Another way to think of it, how far left does this graph go? It's going to keep going left forever and ever and ever. How far right is this graph going to go? Forever and ever and ever. It's just going to keep going up and to the right. Now our range, what y values? Well, we have an asymptote at the x-axis, so we know we're never going to go below. This graph will never cross the x-axis. So the lowest it'll go is just right above 0. It'll never touch 0. It'll never cross this x-axis. And then it'll go to the moon, right? So it's going to go all the way from down here, really small fraction, really small value, and it's just going up from here. So our range is anything greater than 0. Y is greater than 0. Our x-intercept, we're never going to cross the x-axis, right? We have that asymptote where this line is never going to cross the x-axis. It's just going to keep being smaller and smaller fractions, so there's no x-intercept. And then we saw that our y-intercept was 0, 1, right here at 0, 1. So we have y-intercept at 1. And lastly, they're going to give us a table, some data points, and we're going to kind of work backwards and write the equation for it. So they give us this line that has a point 0, 4, 1, 16, 2, 64, and so on. And we're going to start with the skeleton of y equals a times b to the x. Well, if we go back here, a is the initial value, and we plug in 0 for x. So let's solve for a when x equals 0. So if x equals 0, that's going to make x equals 0. We can just go up to our table right here, right? X equals 0 and a equals 4, right? Because it's just the value when x equals 0. And then with b, we're going to plug in x equals 1. So we're using this point right here. And we're going to take the y value divided by a. Well, we just found out that a equals 4, and our y value up here is 16. So what's 16 divided by 4? 16 over 4 is 4. So both our a and our b are 4 in this instance. For the homework, if you struggle on any of the problems, either use the question help button in the top right or call me over. Let me know what you got.